want to give you today a brief introduction how lens elements are made. Let's get started. To illustrate the difference between lens elements, I created a small table that compares polished glass elements, molded glass elements, and plastic elements. The last two are typically spherical to give you a little bit more design freedom. This is the first category I want to start with, the design. Obviously, any lens design has to fulfill the requirements, otherwise it wouldn't make sense to even pursue it. So if we look into design, a lot of our traditional and even new designs are done purely on polished glass elements. So if we take this as the baseline for very good designs, typically, especially in combination with aluminum barrels, we have a very high thermal stability and very good environmental reliability performance. Molded glass stays in the same material family. However, through introducing a spherical, you create a couple of more degrees of design freedom, maybe to optimize performance or compensate for something, or even potentially to reduce the overall amount of elements needed. When it comes to plastic spherical elements, they are often introduced to reduce size, increase performance, potentially also reduce cost, but I will get to cost later. But plastic spherical elements are great if the temperature range where the camera will be in is supporting it. Obviously, in each category, there are a lot of different material choices that should be considered carefully. The next category I quickly want to look into is prototyping. So here we have in-house rapid prototyping capabilities at Sunex. We can do potentially diamond turning, we can work with our supply chain just to create traditional manufactured polished glass elements. We have our own coating machines in-house, we have compression molding systems in-house, and we can also create the cavities for instance, compression or glass molding. Plastic molding. So we also have diamond turning in-house, which again can be applied to all three. It depends a little bit on the shape and material choices. For instance, with plastic prototyping, you want to make sure that you pick a material that can be diamond turned as well as later injection molded, so you avoid a material change throughout the design cycle of the program. The next, if we're moving towards mass production, how about tooling? Traditional glass manufacturing process doesn't require actual tools. It's more like jigs and fixtures to mount the lenses during the manufacturing process or later in the coating process. So again, not too many tools here. Molded glass elements require compression molding systems, and plastic elements require tooling. Depending on the monthly throughput, the overall program lifetime, you will have to decide whether use 2, 4, 6 or 8 in cavities. But here there can be some upfront cost when it comes to tooling, and on the molded glass side as well, tooling costs can again vary depending on throughput. Once the system is set up, we're looking at lead times, then we actually see that the aspherical plastic elements have the shortest lead time. It's a big advantage here because once the system is set up, you can just crank out plastic elements. Again, depending on the number of cavities you have, you can have several thousands and hundred thousands per month. So there's hardly a limitation here. Glass typically has a lead time of 12 to 14 weeks if it's polished glass, because simply the manufacturing process takes some time. And molded glass, depending on your approach, there's prefabricated glass elements that you can use, so there is a certain advantage as well. Again, I can only caution here to consider also throughput, because there can be some bandwidth limitation, for instance, with molded glass elements. And the last point, obviously interesting, how about the cost? If you just compare a lens of small size, then obviously introducing plastic is always a good way to do some design to cost and bring the overall lens cost down. So plastic definitely has some big cost advantage. We maybe take our regular polished glass as the baseline, and then we see that the molded glass is a little bit more expensive. But again, here it's really important to compare the details. This definitely holds up for a small super fisheye lens, but if we move towards a larger projection lens, depending on the plastic material you choose, you can easily actually have cost of a large first element that are comparable with glass. So please keep this in mind. Again, this should be the short overview of how glass elements and lenses are actually made. Thank you.